Hello, my name is Michael Steele. I'm one of the teachers in the Math 3 or Accelerated Math 3 cluster for the 2022-2023 school year. And my work here is going to be focused around providing you tools to support you as you work through the Math 3 Essential Skills Quiz model. Trouble saying Essential Skills Quiz. I'm going to try a little bit harder on that. In any event, though, the purpose here is pretty simple. I'm going to provide you with some support and talk you through the problems on that Essential Skills Quiz so that when you take that thing every few weeks or almost every week, you'll be prepared to really ace that thing and to know not just how to do each of these problems, not just know the answer, but to know the approaches and sort of what the thinking is and why those things are on the solutions like they are. So in this first video, we're going to be working through the first of those questions or topics, which correspond to question number 1, which focuses on intervals. Without further ado, let's attack it. So the first problem we're going to face is, of course, question 1a. I'm going in order here for the most part. But all 4 of the problems in this section, if memory serves there are 4, are focused on taking a graphed inequality, a two-dimensional inequality, by the way, and stating its solution in interval and inequality form. So basically, you're going to be providing 2 separate answers, if you will, to describe this thing. One is an interval using interval notation, and one is an inequality using, inequalities. The old classic elementary school, the alligator eats this one, or eats the bigger number, all that good stuff. So each of these is going to be sort of its own little challenge. So to kick things off, let's set up each of these pieces in 2 places. So first we're going to have interval notation, and forgive me, but I'm going to probably just copy this over for the next part. And then we're also going to have inequality form. In a sentence, these are describing the exact same set of numbers. That's what we're doing here. We're describing sets of numbers, like a collection of values between 2 numbers, or sort of bounded in a way. And that's what we're going to aim for. So basically, what I want to do first is talk about a couple little individual pieces here. In particular, the things that we need to focus on are first sort of betweenness. Like, it's easy to describe like what's happening with an inequality or an interval if we're literally in between 2 numbers, but when we're not, it's sort of harder to see when you're going outside. So what I'd encourage you to think about as you get started here, or if you're struggling to think it through, is to think of the left side, the biggest negative number you can have, aka kind of the smallest thing you can get to. Well, there is no smallest number for a lot of reasons, but we just call that negative infinity. We'll say that's the smallest thing that we can get to, or it's the largest negative thing. It's a good way of saying it's like really, really big, but negative. On the flip side, on the other side, we have positive infinity, which we don't have to write the plus sign, we'll just write infinity instead. So basically what this allows us to do is to see that each of these pieces, at least interval-wise, is going to be between 2 different values. So the first interval is going to be in between negative infinity and negative 32, and the second one is going to be between 26 and infinity. And that's going to actually help us get started here. So to start with, I want to point out that these are x values. We're going to choose to think of them as x values. They're along a horizontal line, so that makes sense. We'll think of them like the x-axis almost. We're going to say x is in between. Now, the first of these intervals, the one on the left, is between negative infinity and negative 32. So we can write that as negative infinity and negative 32. I'm leaving the brackets out here. We'll get to that in just a second. And then, of course, there's a second inequality here, which is from 26 to positive infinity. So, huge start. We've got our 2 pieces. The next thing we should consider is how do we connect these? Well, it's going to include numbers from either of those sets. So we're going to include this symbol, kind of like a U without the little tail. That is called the union symbol, and that union symbol is going to join them together. Now, as far as the brackets that we put around, in order to make these proper intervals, we need to decide whether or not we're going to be using a hard bracket or a soft bracket. And there's a pretty firm way to tell. If you have a soft bracket, you're not including the number. That would be what we see if we get an open dot. So in fact, I'll draw that up here as sort of a quick little tip. If you have an open dot, that's going to correspond to a soft bracket. So again, those are called soft brackets. And on the flip side, if you have a closed dot, a filled in dot, you're going to use hard brackets. Now, of course, that doesn't necessarily solve or fix every single problem for us because of the fact that we have infinity there. What do we do with the infinities themselves? And the truth is, for infinities, we're always going to choose soft brackets. Because infinity isn't exactly a number. It's not like you can count to infinity. It's just a way of saying the largest thing that we can describe. It's basically as big as we can describe something. So based on that, we can go in and add our brackets here. So in this case, we're going to have soft brackets or parentheses around the negative infinity, as well as around the positive infinity. And then for the negative 32 and 26, you'll notice that we have closed dots or filled in dots in each case. That indicates we're going to use hard brackets each time. So I'm going to use a hard bracket right there and a hard bracket right there. And I'm going to go ahead and caution you right now. If you're one of those people that's like, I can totally beat this system. What? They'll never know whether it's hard or soft. Yeah, we're just going to mark that wrong. So, nice try. Kudos for thinking, but not going to do the trick. For us, though, the important part is there is our inequality, or however you want to think about it, represented as our interval. So that is that graph in interval notation. Now, inequality notation, that's a little bit more traditional. You've probably done this before. When we go to inequalities, we won't need to draw the negative infinities, even though there's sort of an idea of bounding that's happening there. Instead, we'll just write these as two separate inequalities. The one on the left is going below negative 32, so it's things that are smaller than negative 32. So we'll say that is x is less than negative 32. And then because of the fact that it's a hard bracket, we're going to use less than or equal to. And then the second one we're going to have is going to be for values that are larger than 26. Once again, it's a hard bracket or a closed dot, so we'll do greater than or equal to, and then it'll be 26. And to tie these together, we're going to use OR. So all the x values are either less than or equal to negative 32, or they're greater than or equal to 26. So with that said, I'm going to pause for just a second just to kind of copy some of our little tools here onto the next page. So we've got them ready, and then we'll attack 1b. Okay, that's going to bring us to question 1b, which is very similar to 1a. The only difference is, in this case, we no longer have closed dots or filled in dots, which means that we're going to be using soft brackets instead of hard brackets. In a sense, the only difference here is that one is what we'd call inclusive, the first one. 1a would be inclusive. This one would be exclusive. In a sense, we're excluding the values of negative 14, negative 1. You can get as close as you want to those two numbers, but you're not going to include them themselves. So we use a soft bracket instead. So having said that, though, a good place to begin, in case you didn't watch the first video, would be to start with what we did before. We'll think of this as negative infinity, infinity to help us with the interval. In any interval notation, we'll start by saying x is a member of, and then we're going to basically describe each of these two intervals as being the numbers in between those two. So the first one will run from negative infinity to negative 14. The second one will run from negative 1 to infinity. As far as tying them together, we use the union symbol that connects the two. And then finally, because of the fact that we've got open dots, and in the other cases we have infinities, we're going to use soft brackets for each one, or parentheses. So this will be our correct interval notation to describe that inequality up at the top. Now on the flip side, we've got the inequality itself. Remember, the big difference with inequalities is that we're not going to write out the negative infinity or infinity. We're just going to say it's either smaller or greater, using the old elementary school alligator eats the bigger number sort of idea here. And once again, we use the variable x. So basically, for the first inequality, we want numbers that are smaller than negative 14. Like negative 16, negative 42, negative 10 trillion. All those numbers are smaller than negative 14. So we're going to say x is less than negative 14. And I am going to leave it less than because, of course, soft brackets do not include the number. So we'll get rid of that little line underneath it. Likewise, for the other one, we need numbers that are larger than negative 1. So we'll do x is greater than negative 1. And to tie these two together, in inequality notation, we use OR. So x is either... Oh, that was embarrassing. You'll learn very fast if you watch these videos that I have trouble drawing straight lines. So anyway, what I was going to say was that x is either smaller than negative 14 or greater than negative 1. And in this case, negative 1 and negative 14 would not count because they are not included since we're using soft brackets. Question 1c is going to be our next piece to attack. And in this case, we have our first of what we would call a conjunction, by the way. So this, in this case, is called a conjunction. I didn't use that language on the previous ones, but let's pop it out there right now. So this is a conjunction because it's strictly between two finite values. On the flip side, we had a disjunction. And it sort of makes sense for whatever reason. A disjunction, there's sort of a gap or a break in the middle, but just so we have the word out there. It's called a conjunction. Now in this case, all the other rules are going to be basically the same. In this case, though, we don't have to worry about negative infinity and infinity here at all because of the fact that our values are in between 5 and 12. So actually, this is going to be a quicker problem than the previous one was. So in this case, what I'm going to start with is first For my interval, I'm going to do x is a member of. And then next, I'm going to look here and say, well, the smallest value x can be would be 5. Now, we're not including 5, but definitely 5. And then it's all the numbers in between up to 12. So we'll go x is a member from 5 to 12. And then because we have open dots, just like so, we are going to use soft brackets. So it'll be just x is a member of 5 to 12 in parentheses. Now, if you look at that and you think, gosh, that's really similar to x and y coordinates, you're right. That's what makes it so important that we include the x as an element of part. That way it's very clear that we're talking about x values here and not an ordered pair on the Cartesian plane. Super important. Now, inequality-wise, I'd say this one's also pretty clean compared to what we did before. We're just between 5 and 12. There's no less than something all the way down to negative infinity or greater than up to infinity. It's just between 5 and 12. So for our conjunction, we'll say that x is between 5 and 12. So literally we place the x in between the 5 and 12. And then we're going to use soft brackets, which translate to less than and greater than symbols. So in this case, we want x to be larger than 5, but smaller than 12. And this is going to be our inequality version of that graph. Finally, we're going to close on 1C, or sorry, excuse me, we're going to close on 1D. I'm just going to add in here as a little reminder the fact that the soft brackets correspond to the greater than or less than. As far as our notation though, once again, just like in 1C, we're provided the two numbers. We're in between negative 17 and 13, so we don't have to worry about going down to negative infinity or up to positive infinity. We're just in between two numbers. For interval notation, we'll start with x as an element of. I mentioned in the previous one for 1C that it's really important to put that here because our intervals can look just like an ordered pair sometimes, depending on what kind of brackets we have. In this case, though, looking at our numeric values, we're running from negative 17 to 13. So in other words, like 0 would be a value in this interval, 42 would not. And then finally, because of the fact that we have closed dots or filled in dots, however you want to think about it, that means we're going to be using hard brackets. So we're going to go hard brackets, hard brackets. There is our interval. And as a reminder, in case you skipped 1A, don't be the person that does something like that. Let's see. Oh, it's a hard bracket. No. Nope. Nice try. Clever. Clever. But no, you've got to be distinctive here. Otherwise, we're just going to mark you wrong. So now inequality-wise, as I said on the previous one, I think the inequality one is even simpler than the disjunctions earlier. And again, this is called a conjunction because we're just in between two finite values. In our inequality, the smallest we can be is negative 17. The largest is 13. We want all the numbers in between, so we'll say x is between those two. And then closed dots, we need to include negative 17 and 13 both. So we're going to do less than or equal to and less than or equal to. With that said, that completes the first problem, if memory serves, from the standard quiz model. It does. Just had to check to make sure. It completes the first problem from the Essential Skills quiz model. So hopefully you found something helpful in here. Got a little bit of sort of a refresher course on intervals and inequalities and how to represent them sort of mathematically using the proper notations. In any event, thank you for watching. As always, I hope these are helpful. Have a great rest of your day.